So the next part that we have here is ex- explain the client server. That was done. Show understanding of thin client and thin client and the differences between them. Okay. So first of all, let me tell you that if you this topic is not that important topic, like it's not a major topic. It has hardly ever come, like once or twice it might have come. Okay, and but still surely we'll understand it. Okay, we will not miss it anyways. Okay, but this is not a very major topic. Like you don't need to have very deep understanding of it. Okay, if you have a good understanding and differences, if you can differentiate between them, then that's a very good understanding that you have reached. Okay, for at least this syllabus. Okay, so let's understand that. First of all, we need to understand that the basic concept. Now, thick client, like thin client, what actually they are. First of all, thin client is usually a client, but actually it is a node. Okay, as we had already discussed in that we have already discussed in the client server model. That client server, all the devices, a node, a device, a client, a server, they all classified as a device. Okay, so what is a client is actually a device in this case, device. Okay, but different uh, types of devices are there. Okay, according to their priority, how much they are according to their dependency, how much they can perform on their own. Okay, for example, if I have a smartwatch, now until it's not connected to my phone, I cannot call it from. I can't even call someone from that. Okay, that watch. But if as soon as it's connected to my phone, okay, then it's like I can call someone because I'm connected through Bluetooth. Bluetooth. Okay, so a little general example that will be taken, not the very exact example, but for this lecture, okay, we will be taking like desktop, not the smartwatch. Smartwatch actually is not classified as either of them because it can perform so many functions, like while you're running, counting your steps, okay, and your heartbeat. So many functions as performed without be connected to the some other device, okay, some server. So we cannot classify that as a thin client exactly, okay. But surely for some supplementary features, it needs to be connected to the internet, okay. So now we'll take the example of thin client like a monitor, okay. Like if it's not connected to the CPU, not to the central server, okay, it cannot at all perform any of the task, okay. Well, if you have just a monitor put down there, so you are not going to able to be perform any task, any specific task. For example, if it's not connected to the net, you are not able to not going to be able to watch movies or do any gaming or any stuff. Okay, so at thick client we will take that will be like for example the Microsoft 365 that we have, Word, Excel, and all of that we have, because that is actually a software application that can work on its own. Okay, since we'll be seeing all of the characteristic of each of them, so we will be able to understand better. For as per processing power, thin client centralized servers. As we saw that, like if you have a monitor, okay, so if you are connected, like if you're playing Xbox 360 games, okay, so then the monitor is connected to the server, to the Xbox 360, to the console. Okay, that time it works. As soon as as soon as it's disconnected, you cannot play any game or do any productive thing out of the monitor if it's not connected to the internet. Surely that is like out of our out of our yes, that's out of our discussion. Okay, so now, for example, local and independent. Now, if you want to write a file, you want to edit a file, you don't have internet connection, it is open Word and you start writing file. That means it's local, like it's locally stored and locally works, and it's independent of any other device. Okay, if you do not have internet, no problem at all. If you're not connected to some other device, not some central server, you don't have any problem. You can still edit the file, create the file, and local storage is also there. Like you can store it locally. Okay, now data storage not stored on server. Now, for example, whatever is being displayed on this screen at least, okay, for example, let's take the very case, whatever is being shown on this screen, okay, it's not stored on the screen itself, okay, like screen does not have any of its own storage. but the store screen is connected to the CPU, to the computer case. So that is the data that is being shown, or whatever it's dealing with, the monitor is dealing with the data that is being stored on the server, that is being stored on the CPU. Okay, and data storage, for example, a Word file, so that will be this, that would be within the like local storage out there in that, you know, in the CPU, where the file is being created, where file is being stored, and where file is being operated. Okay, network dependency. Okay, now data depends for thin client. For example, if you do not, if you have a monitor, you have an LED. Okay, high needs constant connectivity. Okay, for example, you're watching a movie and suddenly, the network fails. Okay, and then like you don't have connection, no more have connection of internet. So what's gonna happen? Surely you'll not be able to, you'll no more be able to the watch the movie. Okay, or like even deal with what you were doing, like what you were watching. Okay, so while thin client like net, like the Word file or the, the other files, that they have very low dependency on network. Okay, they can operate offline. Okay, like what if I just want to write a file, and if I want to edit it, if I don't have internet, that doesn't matter, since you all know. Okay, well, it's not dependent on the internet for that, for its working. Okay, maintenance centrally managed, straightforward, like uh, this LED that we have. Okay, its maintenance is not so complex. Okay, well, it's not complex to like thin client. Okay, like most of that the maintenance that is there, that is actually of the internet or of the CPU or of the Xbox console that you have connected to. Okay, it's that it does not have its own, maintenance, the LCD, so much of it. Okay, but in maintenance over here, individual device maintenance. And now individual device maintenance, for this point, we can, for this characteristic of the thick light, we can even take the example, like remember our standard PC laptop that is there. Okay, that is the you know perfect example of thick light. Okay, because like it's, you can even compare with the characteristics. It's local independent, like it can perform lots of tasks on its own. Then local storage, like a laptop, you take it wherever you take it, the storage is already there. Yes, you can use cloud storage as well. We'll study what's cloud storage. Okay, but you also have good enough, RAM and ROM within your, computer case. Then it can operate offline. Yes, it can surely operate offline. Individual device maintenance, like for example, if you have charging problem or some other, your port is broken, or like any other problem that you have, storage, when less storage is remaining, you can even install more storage, get more storage. So individual device maintenance, that is actually quite a task. Okay, like it's not easy to carry on a laptop for a good amount of years. Okay. Then next point is cost. Okay, as per cost, surely think client, that is just an LED, that's to be connected to the Xbox console, and you are going to play the game in it. That doesn't cost a lot, but cost of a thick client like a PC or like a laptop, that is high due to robust hardware. Like specific hardware is been dedicated for the, for example, laptop. Okay, like it will have the RAM, ROM. Okay, and the screen and all of it will be there. So surely the cost will be higher. Okay, then performance. Okay, limited by network and server. Surely this LCD LED, the that one, the monitor will, that will would have, that would be very good, like if were the very large screen, you can, and you can, but the resolution, the resolution that is there, that is high, and so the experience is much better, but limited by network and server. Like if your server, like if your network, if you have a network connection failure, so the all the benefits of the performance that are there, that are limited. Okay, that are stopped. For example, as the network, unless the network connection fails, you don't have any benefit of having a good experience, because the movie cannot even play. Okay, but performance high, suited for demanding application. Okay, like a PC, a standard laptop has a very good performance, because it can perform a lots of tasks on its own. Like play, you can even play games on it. You don't need a Xbox console for laptop. Okay, so its performance is very good, and even without network, can do lots of fantastic tasks. Okay, scalability, easy and cost effective. Like it's easy to, for example, if you have a monitor, you can add a monitor and a monitor, and it's kind of easy to scale up the setup. But as per the thick line, like laptop, okay, so it more expensive. Simply, it's more expensive to buy as a laptop. Like, they actually mean that. Okay, so now just take an example. You want to find out that like it's thick line or thin line. Just compare with these, you know, differences and the characteristics of each of them, okay, and you'll be able to classify them easily. Okay, so these notes will be available. You can memorize them. These things are worth memorizing. Okay, if you have understood them, while explaining, you can explain things like a thick client. For example, standard PC, it has local and independent, working. The processing power that is there, processing is local. It's done on the CPU, like in the standard laptop. Okay, then for the local storage, it's used, like for the storage, it has the local storage like RAM, ROM, and that all. It can operate offline. So you just compare with these characteristics. So if the device matches any of the all characteristics, then you are going to classify it as either of them. Okay. So I told you before that's not a very main topic. Okay. Like it's hardly ever discussed, but still we should be perfect in that even. Okay. So the next part that we have here is show understanding of the bus star mesh and hybrid topologies. Okay. Now actually, like we had learned like client server model and how the B2B model, how they are connected together, how the connection is made up. Okay. But actually in a small LAN, it's like usually a LAN, the topology especially for a LAN. So topology is actually like the architecture and the way they are connected, the connection. Okay, like they are connected through wires. Okay, they are connected. Which one comes first and how are they connected? Like we'll see what actually they mean by topologies. Okay, understanding how packets are transmitted between two hosts for a given topology. We had learned like they are how two computers in one university are connected, but how data goes through them and like what way it goes. Okay, so we according to every topology we'll see that. Justify the use of topology for a given situation. So according to disadvantages and advantages for each of the topology, we will be seeing which situation is the one it's likely to be for. Okay, so let's move to that. Oh yes. Okay. So first of all, here the definition there, a topology is simply the physical or logical arrangement of devices in a network. Okay, so that before the one we had, that was model like how are they connected. This is the logical arrangement according to the sending and receiving of the messages and how they should be sent, how and which one is sent first. Okay, so first of all, the one we have, let's start straight away. Okay, these definition and these both the keywords. Actually, the key to marks is actually the keywords in at least paper 1 of computer science 9618 A levels, okay? ALS levels. So if you know these keywords like simple and logical arrangement, okay, and star topology, okay, so then you can even make up your own definitions. Otherwise, if it's hard for you to remember, so you should memorize it. You should memorize those definitions even. Okay. So let's come to now see. This is a very good elevated arrangement of the like and how the device in the star topology are connected. This is a small server, the small switch or hub between them, okay, that connects all of them. Okay, what switch or hub is a device level. If you have a 16, you have 16 computers, let's say 16 computers in your computer lab, okay, and you have one router to connect all of them, okay, if they are to be connected with wired, okay, so what do? You can The router usually doesn't have so many ports, so you take a wire, then you get a router, you get a switch, okay, and you connect the switch to the router. Now switch actually has, from one side it may have 16 ports and from the other side one port, okay. So then you connect all the 16 computers to that switch, okay, and connect the switch to the router. So it's actually like you connected all the 16 computers, all the 16 devices to the router actually, okay. So it's a very simple device, okay. can you search about it? That connects multiple like devices. Okay, now see this. Now it has so many of the ports that are going from one side. That means you can connect so many devices with it. Now see, this is a very good illustration that is given. Okay, like receivers. Okay, so all of them are connected to switch. Okay, so one sends to switch and it goes to all of them. Okay, for example, if it has to send all of them, okay, or it has to send to specific. Now remember this thing, if it has to send to all of them, like it does not, the switch does not need to classify or does not need to specify to whom should the data go. That is not a switch, that is a hub. Okay, if it is, if like the path is to be specified, for example, the sender has to send the data only to this receiver. Okay, so it's going to be a switch. Okay, but a hub cannot do. Hub will send data to all of them, all the devices connected to the device, all this the hub. Okay, but but switch will need a specific address and it will, you know, transfer the data to the specific address head. Okay, so that was the switch actually. So this would happen. Every device connects to a central hub, central central device such as a switch or hub. Okay, so if it has to send data, so how would the data be, for example, if this has to send the message to this person, so first data will go to the switch and then it will go move on to the receiver, sender to the switch to the receiver. This you have to remember how data is transferred, that they can ask in the paper. Advantage is, if the one cable fails, only one computer is enough. Now see, this sender had to send a message. Now if this cable is cut, okay, like if this cable is short, so like there's a problem with this cable. So other, if this has to send data to him, there's no problem at all because of this cable. Okay, because of failing down of this cable. That is a very, straightforward thing to get, and easy to identify faults. Okay, for example, if this device is not able to connect to the, or is not able to send the messages or receive the messages, okay, so that means this device or this wire has fault. Okay, that is easy to identify. Easy to add or remove devices. If I just remove the connection of this device, okay, from the switch, so this device is removed without affecting any other connection in the network. Okay, and good performance, surely, it's very easy to send the message. At one time this can send to him and then this can send and then this can send to him, and that's very easy actually. Okay, this one requires more cable than bus topology. We'll see what the bus topology is, but you need to do this, that every cable needs to, every device needs to have its own cable and then gets connected with that. Okay, if the central switch fails, the entire network fails. Now, the central switch to whom all are connected, if this fails, okay, so if this sender sends the message to this, so it will come here and it will be lost. Okay, so he's not going to receive that. If he sends, then he's not going to receive that. Okay, so that means if the central switch fails down, so there's nothing, like the network has fallen down and it's no more working. Okay, so the, like it's down and, you know it's faulty. The whole network has fallen down. Okay. Now more expensive, like it's actually the switches and the wires that they already said more cables. Okay. The more cable that are more expensive. Okay. So that's actually it. This is the most common topology in modern lands. Okay. Like it's specific limited geographical area, so you'll use star topology. Now come bus topology. Actually, bus topology, the basic concept is that within one wire you have a long wire. Okay, let's maybe try if we can create one. Okay, and then you have one device here. Okay, and second device here. Okay, and the third device here. Okay, so they're actually all connected to the same cable. So if this has to send a message to this one, so it will straight away send the message away. Okay, okay. Okay, so this is how actually you see in one cable all of them are like in one or two cable, all of them are connected to each other. So if this has to send message to this one, so the message will go from straight from the wire to the wire. Okay, there is no centralization in it. Okay, it's like you can compare it to, it's not, but the concept that is used in P2P model, that the same concept is used in this typology. Okay, you should, if you are comparing it even, you should specify them with different wordings. So all devices are connected to a single main cable called the backbone cable. So this cable that is there that connects four of them, that's actually called the backbone. Cheap to install. So one cable is there, so it's easy to install. Then you had for मतलब, one for start topology for four devices you would need one switch and four wires. Here you need only one wire, so it's way cheaper. Use less cable. Okay, yes, we already got that. Easy to extend for small networks. Like if you have four networks, so simply just you connect your device to that network, okay, to that wire. If you are able to connect your device to the cable, you are connected to the network, to the internet, okay. Disadvantage, if the backbone cable fails, if somebody just cuts that wire, so the whole network is going to fail down, the whole network stops. Performance decrease as more devices are added, difficult to identify faults. Like, like if this device has, here there's a fault, okay, so no device will be able to exchange data among themselves, okay. So that's where there's a difficult to identify faults, and performance decreases since more and more devices are there, okay. So data will have to go to more and more devices and check whether this is the right destiny or not, the right destination where the data will ask itself, is this the right place that I have to reach by the IP address and whatever it does, okay, by the private IP address really, the LANs, okay. So it it is, if it has to check more and more devices whether it's connected, so that will be harder for it surely, so performance decrease as more devices are added surely, that is another thing. Example, mentioning the failure of the backbone cable is a very common mark point. Usually, the every technology, every concept has something very like common and very apparent in it. So you need to always, whenever you mention that thing, you should mention it whether they ask or not. For example, if they ask you about the thick client, thin client, you need to always mention the processing power. They ask you about bus topology, the backbone cable, okay. And if they ask you over here about the star topology, okay, so you need to like mention this here, like the central device, central switch, okay. So this is further, if you central switch, it can kind of describe the whole network, okay. For the star topology, it has, you can even remember it, the one that has the central switcher hub, okay. So this is very good point that you should mention whenever they ask you for the definition of something, you should mention one good and very common characteristic of it.